This is Darren Marchant with American Nomad News, and we are reading a portable document file today called Bulletin of the Atomic Scientists by Samuel Black and Yusuf Butt. The preamble at the top says, "The growing threat of space debris." There's a little serial number, DOI:10.2968/066002001. The growing threat of space debris. The danger to orbiting satellites. Space debris has been known for decades, yet accidents and intentional anti-satellite weapon tests still pose serious threats. Better rules are needed to govern increasingly busy near-Earth space. Adjust the screen here so I can read this. The United States is heavily reliant upon satellites. These satellites save lives, strengthen the economy, and provide invaluable support to the military and intelligence services. To wit, there are approximately 300,000 emergency GPS receivers used in the United States to aid search and rescue teams, and the space industry supports about 729,000 U.S. jobs. During the 2003 invasion of Iraq, precision-guided munitions, most guided by GPS-based satellite navigation, made up 2/3 of all the bombs used. Superscript 2. Yet satellites are also highly vulnerable. The space environment is a harsh vacuum that is constantly swept by solar storms, naturally occurring meteoroids, and a hail of fast-moving space debris. Most satellites travel at speeds ranging from 3.1 kilometers per second to 7.8 kilometers per second, many times faster than a bullet. Superscript 3. When satellites and space debris collide at such speeds, the results can be catastrophic. In peacetime, the consequences include damage or destruction worth many millions of dollars and a gap in satellite services. If a collision occurs during a crisis, it could be difficult to tell whether it was an accident or a purposeful act, which might exacerbate tensions or spark an armed conflict. Space debris also could damage communications and internet intelligence gathering satellites when they are needed most. Similarly, anti-satellite or ASAT weapons tests pose enormous risk to both satellites and the space environment more generally. Thus far, such tests have been relatively rare, but China's 2007 ASAT test and the U.S. destruction of a defunct spy satellite a year later have raised fears of further tests. Both tests created space debris, but because the United States destroyed its satellite at low altitude, the debris burned up in the atmosphere in less than a year. At the bottom of page 1, it says Bulletin of the Atomic Scientists, www.thebulletin.org, March/April 2010. Now you know where to go to find the portable document file on this. The debris consequences of the Chinese tests were far more severe. It generated some 150,000 pieces of debris larger than 1 centimeter and roughly 2,500 pieces larger than 10 centimeters. Pieces of debris between 1 and 10 centimeters can damage satellites but cannot be tracked reliably with existing space surveillance systems. Pieces of debris larger than 10 centimeters can be tracked and can destroy satellites outright. The debris from the Chinese tests is concentrated at an altitude near 850 kilometers and has doubled the likelihood that a satellite at this altitude will be struck by debris during a typical 5 to 10 year service lifetime. Superscript 5. I must have missed a superscript in there. I wonder where I missed it. Let's go back and take a look. U.S. destruction of defunct spy satellites a year later have raised fears of further tests, superscript 4. That was on the bottom of page 1. Recognizing the danger, scientists have become progressively more aware of the risks posed by space debris since the start of the space age. In 1961, NASA technical paper concluded that naturally occurring space debris, such as micrometeorites and other small natural objects trapped in Earth's orbit, posed a definite hazard, but the danger could be only poorly assessed. By 1978, NASA scientists knew enough to understand that a chain reaction of debris collisions might render space operations prohibitively risky in highly populated orbits. Around this time, NASA scientist Donald Kessler noticed that the upper stages of Delta space launch vehicles that had been left in orbit were exploding. I should note at this time, in the middle of this reading, that the Kessler syndrome is related to this whole subject. Creating debris that could endanger upcoming space missions, NASA engineers soon developed a fix for the exploding rocket bodies, ensuring that no unused rocket fuel remained in the orbiting rocket stages after their missions were completed, and convinced colleagues in Japan, who were under contract to build Delta rockets, to make similar changes. Eventually, awareness of the space debris problem led to the National Security Council to request a U.S. policy study on ways to mitigate the problem. The study was published in 1989, after which the NSC offered other spacefaring nations briefings on the subject. Bilateral meetings were conducted with the European Space Agency, the National Space Development Agency of Japan, and the Russian Federal Space Agency. Later, the four agencies created the Multilateral Interagency Space Debris Coordination Committee. Over time, space agencies from Britain, France, India, Germany, Italy, and Ukraine became involved in the committee, promoting broader and deeper knowledge about space debris. Oh, and I keep missing the superscript, so I'm just going to skip them. Please look them up when you look up this portable document file. The group began making presentations to the UN Committee on the Peaceful Uses of Outer Space. In 1997, technical debris mitigation guidelines were submitted to COPUOS in 2002 and were officially endorsed by the UN General Assembly in December 2007, but this endorsement was not legally binding, thus implementation of debris mitigation guidelines remains in the hands of governments of spacefaring powers. If you're gonna make one of these names, never mind, I'm not even going to get into it. COPUOS. Who thought of that? A continuous threat. Unfortunately, existing efforts to prevent the creation of additional space debris are flawed in two important ways. First, destructive ASAT tests, each of which can create as much debris as is produced in decades of peaceful space operations, are addressed only tangentially by existing laws. Second, there is a lack of rules of the road for space. As more satellites populate orbits around Earth, the risk of collisions grows. For instance, on February 10, 2009, a satellite operated in the private company Iridium and a defunct Russian satellite collided, producing roughly 100,000 new pieces of debris larger than 1 centimeter in low Earth orbit, a region 200 to 2,000 kilometers above Earth's surface that is already densely populated with both debris and active satellites. Somebody asked me recently in a discussion where I was promoting the idea of recycling orbital debris in order to use that material to design on-orbit manufacturing, if there was enough material in space to bother with to continue to do that. Well, this paper definitely points out that there is tonnage available, and that every year we're adding more. So it seems to my mind that my point is proven in that regard, that recycling titanium and aluminum and iron and chrome and copper and gold that is likely to be found in these satellites and other materials is definitely going to be available, and deorbiting is not as practical as capture and recycling. And there's more points in the paper later that come down to the point that deorbiting increases the risk to life down on Earth, even if it is by law supposed to be in a lower percentage. But we'll get to that. And we're going to pause right here for just a minute. It caused a roughly 70% increase in the amount of dangerous debris at 570 kilometers, the altitude of the Hubble telescope. Fortunately, most of the debris at the lower altitudes will burn up in Earth's atmosphere over the next decade. Since the collision, the U.S. Air Force has taken important steps to address the problem. It has expanded the number of space objects it monitors to determine the risk of collision, providing the advance warning needed to plan avoidance maneuvers. If necessary, in the past it focused only on so-called high-value assets such as the International Space Station and certain military satellites. But now it reportedly performs analysis on some 800 satellites and plans on adding an additional 500 by early this year. The Air Force is also taking steps to enhance its capacity to track space objects as small as 5 centimeters in diameter. While these unilateral steps constitute a much-needed improvement, it remains to be seen whether they will be sufficient to prevent future collisions or whether further unilateral or multilateral steps will be necessary. Seems pretty obvious to me that the best way to avoid a collision is to remove the material from orbit, and that small objects are incredibly hard to track and would be prohibitively expensive to deorbit. So one of the best ways to get them out of orbit is to capture them, take advantage of the already applied fuel that it costs to put it in orbit, process it, produce equipment from that material on orbit, and therefore you have a controlled material. It is estimated that a collision between an active satellite and a piece of dangerous debris larger than 1 centimeter will occur on average once every 2 or 3 years over the next decade. NASA contends that existing satellite debris shields can protect against impact with such dangerous debris. Even if true, there are more than 300,000 pieces of debris larger than 1 centimeter in low Earth orbit, and fewer than 20,000 of them are tracked regularly by the United States. And those are going to be the ones that are bigger because they're easier to track. Bigger than 1 centimeter. Those smaller ones are going to be the ones that are hard to catch. Aside from posing a risk to satellites, debris threaten better protected manned spacecraft as well. On March 12, 2009, the crew of the International Space Station was forced to evacuate to a docked Soyuz spacecraft in response to a debris fragment's predicted close approach. Another piece of debris threatened the station 4 days later. Then on March 22nd, the space station and the docked space shuttle were forced to change orbit to avoid an approaching Chinese rocket booster fragment. Although both manned and unmanned spacecraft can be maneuvered to avoid potential collisions if enough warning is provided, such maneuvers use limited fuel, which can shorten the operational lifetime of the spacecraft and disrupt data and other satellite services. In some cases, it can take many hours to plan and execute such a maneuver. For the International Space Station, for example, it takes approximately 30 hours. Furthermore, because there is very little atmospheric drag at the high altitude associated with low Earth orbit, debris can remain there for decades. Independent studies predict that roughly 1/4 of the debris larger than 10 centimeters created in the Iridium collision will remain in orbit for more than 30 years. Roughly 15% of 1 to 10 centimeter debris is expected to remain in orbit even longer. So it's available. We can go get it. The threat to satellites in low Earth orbit is heightened because most are not in equatorial orbits, but rather in polar or near polar orbits. Because all satellites in such orbits cross above Earth's poles, the risk of collision near these two spots is dramatically higher than the risk of collision at any other point during an orbit, creating a polar bottleneck. The spatial density of satellites over the poles is approximately 10 times greater than that over the equator. Except right at the poles, there's almost nothing there because of centrifugal force. It's very interesting. As a result, the debris problem is exacerbated by two crowding problems: the concentration of debris at certain altitudes and above the frequent high-speed approaches occurring over the poles. Mitigation efforts. This is where, in my looking at things, they're intentionally blind to certain options, and they will not entertain them. They're fixated, and they cannot think outside this box. NASA simulations indicate that even if no new satellites were launched, collisions would continue to occur in low Earth orbit and increase debris. Since additional spacecraft and the rockets needed to deploy them will continue to be launched, the actual situation is likely to become much worse. Any additional destructive ASAT tests will also add to the problem, like India's last year. A single ASAT test that destroys a 1-ton satellite, the approximate weight of the satellite destroyed by China in low Earth orbit, would produce the same amount of debris that accumulates over several decades of normal space operations. That's 1 ton, mostly, of refined metals. And satellites targeted by ASAT systems could be 10 times larger. In other words, a single ASAT attack could undo decades of careful debris mitigation. Luckily, recognition of the space debris issue is now widespread, and many countries have expressed willingness to take steps to address it. China's 2000 white paper on space activities, for example, stated, Beijing will continuously make efforts to explore, together with other countries, ways and means to mitigate and reduce space debris and promote international cooperation on the issue. India's delegation promised in 2007 its full support and cooperation with COPUS's efforts to prevent space debris. That's how I'm going to pronounce that acronym. An acronym should really, if you're going to make an acronym that long, arrange the words so they spell something that makes some kind of sense. The U.S., French, and Pakistani delegations all made similar statements in support of efforts to mitigate space debris at COPUS meetings in 2007. In addition, a number of diplomatic initiatives have been proposed to address long-term debris consequences of destructive ASAT weapons. China and Russia have submitted a draft treaty at the UN Conference on Disarmament that would seek to prevent the placement, use of weapons in outer space. The U.S. government and many independent experts, however, feel that draft treaty was serious flaws, ergo, that is to say, E.G. The absence of prohibitions on the research, development, and deployment of ground-based ASATs, such as the one tested by China, and the absence of any verification measures. I don't care what laws you make. China decides to go to war with the West. They're going to ignore all the Western-inspired laws about killing our military satellites because they know it's a tactical issue. It's stupid. Build an infrastructure that can attack the problem from orbit. That you can go into orbit and use mass-produced drones that are capable of sweeping these orbital paths of orbital debris, like a broom, picking them up, capturing the material, and returning it to a central orbital location for processing, and turn it into a new equipment, spit that equipment out to go back into orbit. And then they can shoot down all they want, we'll just keep making more of them. Another initiative is the European Union-sponsored voluntary code of conduct that addresses issues such as space traffic management, debris mitigation, and the destructive ASAT testing. By agreeing to certain rules, states would clarify responsible and irresponsible actions, facilitating responses to the latter, which would include debris-creating events. But China, Russia, and others have expressed a desire for legally binding agreement, a condition that the European Union Code does not satisfy. Of course, because People like to write rules. They don't like to follow the rules they write. A third initiative is a narrowly focused proposal that would ban destructive testing against space objects. Such a treaty would directly address a pernicious source of space debris without approaching many of the contentious issues entailed in the more comprehensive approach taken by China and Russia. China and Russia, get me started. The idea was broached in a 2008 workshop organized by Henry L. Stimson Center, where one of the authors of this article was employed, but no country has formally endorsed it. This is not really a solution. It's a rule. No international consensus exists on which of these approaches would enhance space security the most. China and Russia remain publicly committed to a comprehensive, legally binding treaty. Honestly, it's better to make a business out of it. Make it so that shooting down satellites isn't going to do anything for a country, and then they're not going to shoot down satellites. And if we can make our satellites from orbit out of orbital debris, then we solve the orbital debris problem, and we obstruct the usefulness of shooting down satellites. The European Union is conducting rounds of consultations with other spacefaring nations on its code of conduct, and discussions on the narrow treaty proposal have so far been largely academic. It is unfortunate that at present an international agreement addressing the largest potential source of debris, destructive ASAT tests, does not appear to be forthcoming. Without it, the international security and the use of space are under threat. And that's the problem with academics managing space, is that, yes, on the technical side they can get it right, but on the tactical side they don't get it. Samuel Black is a research associate at the Henry L. Stimson Center. Previously, he was a research assistant at the Center for Defense Information. He holds an undergraduate degree in government and politics and a graduate degree in public policy at the University of Maryland. Yusuf Butt is a staff scientist at High Energy Astrophysics Division at the Harvard-Smithsonian Center for Astrophysics and is currently on leave at the National Academy of Sciences. Previously worked on NASA's orbiting Chandra X-ray Observatory project and served as a research fellow in the Union of Concerned Scientists Global Security Program. Holds a PhD in experimental nuclear astrophysics. And there are notes. Looks like, just about 2 pages worth of just notes. And I am not going to read that stuff. So this is my reaction to this portable document file, Bulletin of the Atomic Scientists, from whatever year this was made. Is there a date on this thing somewhere? Maybe way down at the bottom? Whoop. 2010. It exemplifies really well the problem. They can spell out the problem. The problem is increasing, and none of the solutions that they are willing to examine are realistic solutions to the problem. It says Bulletin of the Atomic Scientists, March/April 2010, Volume 66, Number 2, pp.1-8. So now you know where to get the portable document file. And it seems obvious to me that the solution is to mass produce satellites whose job it is to be active drones that are serviceable and refuelable and bristling with sensors and 360 cameras pointing in all directions that sweep through orbital pathways in formation, just like a bunch of airplanes flying in formation, and mutually communicate and scan that orbit as they go around multiple times. And every time they register an object, that goes in their map and that map is updated until each of those items, all the way down to a single centimeter size, and is tracked. And then the orbits of these drone swarms is adapted so that they don't interfere with each other, and each one is assigned to pick up these small debris, which are the biggest, most serious threats. Because the bigger stuff you can avoid, you can see it coming. The smaller stuff has to be swept up like a broom. You capture these things and return them to an orbital space station whose job it is to produce a product. The product is taking these refined metals and reprocessing them into new stock materials and turning those stock materials over to people on orbit who produce satellites, space stations, life support systems, whatever is needed. And then the fuel that it took to put that refined metal in orbit is effectively taken advantage of. Otherwise, you deorbit it, it turns into hazardous objects and dust, and largely goes back into the oceans, and we're never going to see those refined metals again. Then if we want more metal, we have to pull it out of land-based mining, and then our land has less metal, and the metal slowly makes its way into the waters and disappears where we can't get at it anymore. It's ridiculous. This is Darren Marchant with American Nomad News on a portable document file reaction.